First thing, usually people wonder, why is this dude named Mouse? Started my life as a little bitty motorcycle racer, so my name, Mouse, was a good nickname for racing. Raced professionally, and name stuck with me for professional motorcycle racing, and moved on to be a stuntman for a while. And it was a good stuntman name, then action movie director, good name. Now I'm a grown man with a kid's name. So I know everybody's here to really learn about the future. We're gonna get there. But sometimes you definitely got to look at the past to have a perspective overall. So I want to start out with taking a little look at the past overall. So, beyond just cool, the automobile has been a cornerstone of man's ingenuity, mythology, and fascination.
You guys ready?
It magically captures the ideals of freedom and inventiveness that drove us straight into and through a remarkable industrial age. The birth of assembly lines, mass manufacturing, and the Model T Ford put a blank canvas in the driveways of everyday America. At the end of World War II, a generation of Americans returned home with a taste of danger and excitement, along with newfound skills forged by operations of the industrial war machine. Everyday life seemed to run at half speed to these young men and women. They had the power to change this. Regular cars could be stripped down to the bare essentials. And using the mechanical skills learned during the war, motors could be hopped up to deliver high performance to these lighter frames. Soon, all across America, these backyard innovators were redesigning and modifying 30 years of mass-manufactured metal to produce lightweight, stripped down, and incredibly fast cars. Each creation an individual expression of form follows function and aggressive performance ideals.
Now let's move on and join the real speed boys of the desert. At El Mirage Dry Lake, those hopped-up cars may look like a familiar old jalopy, but their innards have been streamlined and given a shot of motorized adrenaline.
The hot rod was born. Hot rodders were the original vehicle hackers. They rescued the automobile from racing into a dull future of generic mass production anonymity by embracing deep customization and radical creativity. They drove what they wanted because they made what they wanted, and they drove fast. What started out as an unruly and dangerous form of racing on the dry lake beds of Southern California rapidly became a highly organized sport of drag racing.
Counter that with count the lap time on our Klondike clocks, a 9.12.
These weekend warriors worked to give their cars any advantage possible over the competition. It was never enough for the average teenage gearhead to simply be fastest. He needed to be coolest. Modifications like the chop top, big and little wheel and tire combos, and stripped down, smoothed out aerodynamic bodywork became de rigueur across America. As young people created their idea of what was cool, with easily accessible raw materials discarded in the junk piles of a rapidly industrialized nation. These mechanical innovators became leading lights in mainstream American motorsports. It wasn't long before the major motor manufacturers were mining this ever-evolving youth culture for ideas and peddling furiously to keep up with the visual language of the hot rod vernacular.
Hey, you got a bitchin' car.
Yeah, I know.
Somewhere in a place where self-taught mechanics collided with beat culture, the coolest cars on the planet were created in the garages of innovators and makers, changing the car industry forever. That also could play here, given the region we're in. The same exact thing happened in the UK, happened around Europe. You had kids that wanted to build what they had in their dreams, in their minds. So imagine when you learn about all this future-forward technology, what that means when kids with that attitude get their hands on it. Imagine being able to run around at large OEMs, large aerospace companies, and do whatever you wanted. That's where we're headed. So what would they create? And I think throughout this whole talk, for me, is like, what do all these tools mean? And to us, they mean we can dream big. We can think completely different about the industrial landscape ahead of us, or what we can build and create. For us, this might be a representation of what we would create. It's our case study, our proof of concept of what these tools are capable of. And by the way, this car was born out of a little bit of junkyards in the dry lake beds of Southern California, but I'm going to talk about her later. So this journey for us kind of came out of entertainment, which is funny enough, came out of thinking, how are we going to make people get interested in this world? So this creative brief showed up on my desk. My now partner was the head of design for Hot Wheels. Everybody remember Hot Wheels? Play with Hot Wheels as a kid? So toy designer, a brand that was sort of flat, and he wanted to go big, and he wanted Hot Wheels for real. He said, I want a whole lot of Evel Knievel, and I want to set some world records. Anybody have an idea what's wrong with this image, though, this creative brief, other than it's a comp? Well, if you've heard of Evel Knievel, he only held one world record, and that was for broken bones. We didn't want to break any bones. So like I said, we set out to go launch some world records, get people going, and we turned that into this.
And here we go in 5, 4, 3, 2, 1.
And big balls and old school math will only get you so far, and we had ways to go. Interesting enough, that truck that set that world record that jumped the length of a football field at the Indy 500 was strung out on the floor with no CAD. Imagine that. So we really wanted to quantify that. We wanted to pull all of that experience, all of that knowledge from the 20th century and harvest it because we had something more ambitious. So I was writing my next movie titled Autonomo. Escape from Detroit. All movies have a log line, and this one is when driving's outlawed, only outlaws will drive. It takes place in this head-on collision that's coming down the road between autonomous systems and sort of this dream of freedom on the open road. Just at the time in Detroit 2025 that young kids with all this technology that we're going to hear about are standing up the coolest car companies in the world and really letting themselves breathe. The first socialized mobility experiment of the United States is laid down and driving's outlawed. Say this isn't going to go over very well. You're going to have some pissed off dudes and ladies, and so that gives the basis for the movie. So having said that, this was a really ambitious big car movie. It had a future vision of mobility 2025. We started to look at it and we're like, all right, we need to create 10 startup brands. We have to prototype 50 cars for the movie. And if you're looking at it conventionally, you'd be like, yeah, dude, 5 years, $250 million, that's about what your budget and time frame is going to look like. That wasn't acceptable to us. And we were also going to be playing around with a lot of crazy designs. And we found ourselves in an interesting place. Like, how are we going to build this movie? Is this even possible? And we got on a mission, looking and researching how kids were going to build in the future. What's that going to look like? And then how are we going to build the movie? And so during this research, I asked myself a question. What would George do? Everybody heard of George Lucas here? Okay, well, funny enough, he had just come off making a hot rod movie called American Graffiti. And he had a vision for a film called Star Wars. Y'all might have heard of it. It was 75, and there wasn't a company in the world that could build Star Wars. Nobody in Hollywood. Star Wars was mechanical and physical. There was no digital effects in that movie. They had to build everything and do it optically. It was a tricky thing. So he said, all right, well, we got to create a startup to build the movie. So Industrial Light and Magic was formed. And I'm sure everybody's heard of that. It went on to spin off Pixar. Photoshop spun out of there. It was a pretty good, cool place. So George created Industrial Light and Magic, and Star Wars was built by a startup. And boom, Hackrod was born to try and figure out and prototype and build a film. And also look at, what if people want something out of that movie? What if they want that car on the screen? They want low volume, on demand. How are we gonna address that? So we got after it pretty hard, a lot of years of research, and here's where we are right now with the project. Imagine that you could design and build the car of your dreams as easy as playing a video game. The Hackrod digital manufacturing platform is connecting virtual reality with artificial intelligence and advanced manufacturing to make this dream a reality. To prove this out, we started by sketching La Bandita, the car that we wanted, but nobody made. Quickly moving from sketch to full-scale photoreal 3D model in virtual reality. Allowing us to perfect the design and aerodynamics digitally, moving back into the physical world and connecting with the Internet of Things. We deployed sensors and scanners to capture 50 years of automotive knowledge. We harvested massive data sets and used them to teach the artificial intelligence generative design engine what a car experiences. With artificial intelligence and machine learning, we have the power of hundreds of engineers at our fingertips, allowing us to grow optimized engineering solutions for our design requirements. These designs are too complex and expensive for traditional manufacturing. They have to be 3D printed. Hackrod is leading the way in large-scale metal 3D printing.
So Mouse, this is the challenge section. It's that node right there that's really going to make or break this chassis. What we're doing right here, like this is the key. Right. If we can get that node, then we can get everything.
We are now ready to print a full-scale car in aluminum. La Bandita is not a concept car. It's a proof of concept of an entirely new way to design and manufacture. And if you can build a car this way, you can build anything. Right there, generative design. That was not designed, that is math. So we added the parameters, force loads, geometry, and loads, and that's what came up. It's pretty interesting how biological it is. Batteries go down the center, so it had a spine that created a rib cage, and that right there probably isn't manufacturable overall. You can see recycled powertrain, so we're using a recycled Tesla drivetrain, batteries. There's a lot of good hardware laying around. So for this project and a lot of projects, you're not really gonna need to, for us, create powertrain solutions. There's a lot to harvest, a lot of recycling. We all know carbon footprint really needs to be addressed. One way to do that for us in low volume is to recycle. So it'll be a body-on chassis design overall, and there's no wasted material in this structure. It's pretty amazing. It's a lot like nature. You don't have a lot of inefficiencies in your skeleton. So it's interesting what's going on with generative design overall. But once again, generative design is useless unless you can manufacture it. It doesn't really add up. So for us, we had to sort of bridge that last mile and create manufacturability. I want to talk a little bit about the last mile because it will be the hardest mile, but I think it's going to tie everything together. So you're going to learn a lot about generative design, a lot about tech, but going back to Adam's full scale is going to be hard. And optimized generative design for large-scale metal printing, we feel is the last mile. That's really going to connect everything and sort of unleash all the potential that we're talking about for product creation here. So we're really proud to be partnering with Siemens right now. We feel they're in the lead for what we need to do. Fantastic company. So with Siemens driving along, technical support, and our CTO, we feel like we're going to be the first people to definitely drive the last mile. And my CTO couldn't be here today, it's Dr. Slade Gardner, so I brought him along in the movie. So here's our CTO.
I'm an expert in advanced manufacturing and materials. I've spent my career inventing materials, manufacturing processes for some of the most high-speed products on this planet. And off of it, I was recruited by Lockheed Martin Aeronautics to work in the Skunk Works. I worked in a group that was specifically focused on advanced manufacturing concepts. We were called Project Lightspeed. And we were going to change the paradigms of manufacturing. And my project to enter that group was to study and to determine how we were going to 3D print the next jet fighter with carbon nanotubes. When I was at Skunk Works, I had access to a lot of very sophisticated aerospace tools. I wanted to share these things. I wanted to create the kind of manufacturing capability that someone with less experience than me could use and build whatever it is of their dreams. For the past 2 years, I've been devoting myself and pouring my energy into 3D printing an aluminum sports car. 3D printing enables someone to go from a CAD design to a part with automation in a reasonably short period of time. In general, when people think of 3D printing, they think of small parts. A lot of people think of plastic parts. My interpretation of 3D printing is a much grander scale, and my interpretation of the utility of 3D printing at a large scale involves things like sports cars, things like motorcycles. So that's what we've been doing. We've been demonstrating that we can 3D print La Bandita, the whole car, demonstrating that, yes, we can build a generative optimized structure with the large format metal 3D printer. The materials work, the process works. There are no physical limitations or engineering constraints. It's just scaling up the machine. I see the path to go from 3D printing to full-scale sports car. You know, when we prove this out using this new digital manufacturing infrastructure, then that's the gift to the world. In the future, this will be as easy as playing a video game.
So, yeah, Dr. Slade Gardner, his last insertion was the 5-foot titanium propellant tanks for Lockheed Martin's satellite program that were validated and approved by NASA. So we're talking about validated, certified parts. Moving on to what does this all mean? Really, what does it mean? Well, it means a small company like ours can dream about doing whatever we want. It means that entrepreneurs can dream, but there's one hurdle left overall. So obviously we're pretty sweet on this car here. You might say, oh, that's a great prototype, awesome. But this car doesn't get greenlit by the big corporate committee. It's got too many problems with it, right? Doesn't have a roof, doesn't have a windshield, doesn't have an air conditioner, but there's a lot of dudes that want it, but probably not enough. So this car doesn't make it through the Valley of Death. So I want to talk a little bit about the Valley of Death and what this means. So the Valley of Death in this interpretation is pure design intent to getting your product to market. That's a huge gap. And that's usually where products crash and burn and all the risk is. So if you're talking about doing a production run of an automobile, you're looking at hundreds of millions of dollars to get that going. Prototyping costs, design costs, testing, and then you got to get into tooling. And guess what? Then you tool up and you got to go make thousands of the same exact thing. And then production engineering restraints start to compromise the design. You're going to end up with a massive inventory, thousands of cars to justify the production run of tooling, and you need more money. Then marketing and advertising was created because now you got to go convince people that they need what you thought was cool overall. You got to think, all right, go buy what we thought. But we're looking at a future where, with all the tools you're going to hear about, that goes away. We're looking at an on-demand economy for a large-scale industrial product. And this is super cool in my eyes overall. You think about even the crowd phenomenon going on right now. You got sites, Indiegogo, Kickstarter, they're becoming product launch platforms. People are creating their prototypes, they're getting pre-orders. Pre-orders, no risk. You're de-risking large-scale hardware. Like, that is a new paradigm overall, without question. And something that I think is super exciting. And so you're going to get into where design that you think is cool, something that you want in your life, products that fit your life are going to become part of your life. We're going to enter an era I call design without compromise, design for your life. And we think that in the near future or now, the consumer is going to become the creator of the things in his life. And that's really our mission right now, is to enable people to have what they want or create what they want overall. So I hope everybody has a great time here, and don't forget about those kids that have access to all of this killer technology and what it really means. It means that anything is possible, and dream big. Thanks for your time, guys.